Hello everyone, I'm Leandro. I'm going to talk about our case, how Lina commented before. So here is the agenda. We're going to talk about a little bit about Fibria and introduce you. Most of you, I think, doesn't know the company. We're going to talk about the case. I'm going to talk about data. So the first topic, how you can see, is I'm going to introduce Fibria to most of you that doesn't know Fibria. I'm going to talk about the case, Regrowth Conduction. In this case, I'm going to explain after what it is. And I'm going to go deep in this case, understanding the problem. And after that, we're going to talk about the project itself, how it was, how is the structure of this kind of project here in Fibria at least, and each step that we do until the delivery. So, talking about Fibria, Fibria is the global leader in the production of bleached eucalyptus pulp. So the eucalyptus pulp is the raw material to the cellulose, and our company invests in the cultivation of forests that are renewable and sustainable source of life. And also, the trees that we plant is trees that we plant, not that we find in the forest and just cut. So we create a lot of forest. And the biggest assets that Fibria has are the forest itself. And we have here inside Fibria an area called Technology Center, who is responsible for the creation of this eucalyptus tree from the first moment when the tree is just a genetic manipulated seedling until the moment that is going to be a tree. So this area participated with us, with the IT area in the project since the start, since before, like in this case, the area started to structure the project and come to us with the case. And we're going to talk more about that after. So, in this graphic you can see the production of Fibria too. So this is the rank of capacity of the production capacity of all the companies in the same business. And how you can see, Fibria has a large capacity. So talking about the case that we have in this project that was the last one that we introduced here in Fibria is the Regrowth Conduction. This case came to the IT team from the business area, and they brought us just this case in like an opportunity to improve our process and to have a very reasonable financial impact. So, talking about that, when you cut a tree here in our business, you have two options. When you cut a tree, we have this structure like you see in the screen, and inside this structure, it starts to grow another growth. And another trees I'm going to start in this. And in this tree that was dead. So you have two options to go. You can reform, or that means that you can kill the old tree and plant new trees in order to create a brand new forest. And you can go to the regroup. That is to select the best fraud and let it develop to create a new tree. So this is the two options that we have. And the regroup is for our financial, talking about business, is the most cheaper for us to introduce, to implement, and the best choice. But we have a lot of things that avoid this kind of practice in some cases. That is, you have to, like a positive aspect, you have the lower cost compared to the reform, and like bad aspects, you have lower productivity. In general, you have lower productivity when you want to do regroup, and you have a lower survival index when you compare forest that was created going from a reform. You see that in general the forest have like more percentage of trees alive at the end, at the moment that we are going to cut the trees. And when you see a regroup, you see a little bit less trees compared to the reform. And when we choose to follow with the regroup and the survival index of a certain forest is too low, it's necessary to opt for a thing that we call reversal. In the other words, the reversal consists in abort the regroup forest and start to conduct the reform in this area. So how you can picture, when we, like Fibria, opt to go to the regroup, we need to be very sure that it's going to be a successful forest. Because if something happens and we need to go and to do this reversal, we're going to expend a lot of money and time. We're going to waste time because a lot of time was passed, and the tree cycle of life is at the most 7 years. So you need to have very good points, very good material to have a good decision. So this is and now we have the understanding of this problem. No? So talking about costs, we have comparing in the first graph chart at the left side, you have the default cost of the reform compared to the regroup. You can see that it's much less. When you implement a forest using the regroup, you expend like 46% less than using the reform. So it's a very important aspect for us. And this point itself sells the product to the business area. No? And comparing the productive capacity and inventory, you have like in the productive capacity versus inventory in the reform, you have like 21% less when you talk about reform and 34% less when you talk about regroup. So all these points motivated the business areas to the business area that was the technology center and the forestal area to go to IT team and start to talk about to do a predictive project in this approach. So, talking about the main objectives of this project, you can say that we have two focus. The first one is to increase the survival index in regrowth areas, to have the survival index much more closer to the survival index that we have when you use the reform, avoiding the reversal in the regrowth area, the entry. How this is the answer that the project needs to answer. No, how can we increase the forest survival? So using the predictive models, we need to explain this question. And the second focus of the project that we can, like doing a technical relation, we can say that is the second target that we're going to treat in the predictive model is going to be to increase the productivity. So we're going to build a model that can see all the characteristics that working together can contribute to increase the productivity, having the productivity as a target. So answering why the productivity in the regrowth areas are worse comparing to the previous cycle in the forest that we have before, that always is an implementation, a new forest. And how can we increase this productivity? So now that you all have this business introduction, we can go to the project scope. Now talking about the objective, we can say that is to increase the survival index and the productivity. And the steps that we do to achieve these goals is to start doing a variables workshop to identify possible variables and sources, data sources in this case. And we're going to explain after all the steps. We go to the data preparation to extract the data that we need to join, to put together and generate a unique table to give to the SAP Business Object Predictive Analytics, to do a data quality, defining the outliers and warranting that the data that we are using is the quality data that's not going to give me like false insights. And at the end, building the predictive modeling. No? So we have here just some context. We have data sources. We have like SGS, that is an ERP that we have here in Fibria, most focus on the forest data and have a lot of interface with SAP. And we have all the other data sources that we need to connect, like the weather one, the spreadsheet that has a lot of data that we need to use in this project. And after this, we go to the structuring data. That is nothing less to do that build the patterns, the rules, implementing the calculations, doing the filters, connections, the interpolations, to go to just to create a database that can be used by the SAP Predictive Analytics. So here in our project, we use a database that is the HANA database, so in memory to have more performance when we are creating the models. And we are going to talk about after what is the good points that this brings to us. And we talk. You can see that we have a lot of variables. We have like 278 variables and a lot of cycles. This cycles is like forests that are treated in this project. And after we go to the final step, that is the modeling, identifying trends and generating recommendations to the business area. So Talking about the first step, that is the variables workshop, we can say that is the meeting that we create here to including the data scientist, Paulo, that's not here today, and business experts who can contribute with valuable information related to the problem being studied. So we put all the people in a room and start to say what can be the variables, the reasons that can be affect the case that we are studying. We put everyone together and start to have some insights, like understand the problem, listening to the experts from the business, clearing doubts, and creating some hypotheses to have targets, understand the process, a better understanding of the process, how in every project that we have in this project, this kind of project is not an exception, helps a lot to create more effective predictive models and define new risk variables. So the other part is to discover potential data sources, so technical stuff, to know all the databases, all the spreadsheets, the views, tables that we can be potentially used in this project, and search for the variable itself, the fields of the table, the information that we need to build the predictive model. So after having had this variable workshop, we go to the next step, that is to connect with all these data sources. In our cases, all these data sources that is just known here in Fibria, you have Excel spreadsheets. We still have this shadow IT here. A lot of databases that contain valuable information that can be used in the project. And this Zenith is a system that we use to have weather data, so the forecast, and not just the forecast, and talking about historical data, and the time that was the weather that we had in that forest each day. So this is important when we talk about the forest. And forest data itself, and SAP too, every kind of database that we use in this project. After that, connecting to this database, we use the SAP data services. That is nothing less than ETL tool that I use to extract, transform all the data, and load this data in the SAP HANA. And one important thing is that the SAP data service needs do all the joins, put all the information together in the same table, because SAP Business Object, Predictive Analytics, needs just one table to relate everything and use to create the model. You cannot say, use the table for the weather, this for the forest data, put together right now for me, using that key that relates all these tables, and now build a predictive model. No, you need to deliver just one database to the SAP Predictive Analytics to start to do the creation of the models. And in the data preparation, you can see that we go from a lot of data sources, and these data sources are tables of data that we use, like inventory, genetics, material, weather, ground cover. These are the source tables that we have. And we build a lot of aggregations, derivative variables, we create another variable, So, for example, we create variables for the weather in the summer, the level of rain in the summer. It can affect the level of rain at night, at morning, at afternoon, at night, and at night. So we create a lot of aggregations, new variables, and we relate together at the end, storing this table, this final table in the SAP HANA, and to be used in SAP Business Objects Predictive Analytics. So, in the next step, we can say that we do with data quality. In this step, we analyze all the data using that histogram, for example, to see how is the distribution of the data, talking about just one variable, for example, and to see the outliers that we can take off and clearing the data to not bring all this dirty, that we call dirty data, to the predictive model. So in this case, for example, we see in this chart, this box plot chart at the right side, that we have like two marks, and below these marks are the data that we need to not consider. So we took off this data, not considering in the model. This is important to create a model that has a very good quality. And talking about the predictive models itself, we start doing the structure database, going to this part, selecting the relevant variables, identifying the targets, and putting this as an input to the SAP Business Objects Predictive Analytics. So the moment that you open the SAP Business Objects Predictive Analytics, you need to select all the variables that you want to consider in the model, and just one variable that's going to be the target. So in our case, we can select like a productivity variable, and all the variables that we want to know the contribution to the phenomenon of productivity, for example. And this is the input to start to build to run the predictive analytics. That's going to do automatic elimination of correlated variables and variables with low prediction power. So you inform like 100 variables to SAP Predictive Analytics, and after run, it will automatically select all the variables that contribute to the target, and is going to take off all the variables that don't explain nothing, don't explain at all the target, and took off the variables to the analysis. The predictive analytics does this automatically. And after that, we have a lot of output. So we have the model performance is an indicator for prediction power and prediction confidence. Prediction power is the quality, it shows you the quality of the prediction that the predictive analytics could achieve with the data that you put for it. And the prediction confidence is the level of, for example, how you can predict this, how, with all quality, what quality is going to be another model using another data with the same model that we generated. And we're going to have the variable contribution, percentage of the phenomenon that's explained for the variable. We have category meaning, identifying ranges of variables that contribute positively or negatively to the target. We have the statistic reports to show you reports that help to understand the model results. You can do like simulations. You have all the variables. The model is already created. You can inform, okay, training this model. Now, going from another data, what's going to be the productivity considering that we have these values for the following variables? So you can have another input. And you can do an application of this model in another data. You can predict the future considering the model that we created based on historical data. This is important. Now, this is the final application of the whole thing. So, seeing the screen of the model at the end, you can see that we have like the filters of the data set that here we cannot put. And the initial number of variables in this model, for example, you can see that we have 861 variables. That's a lot, with a lot of rows. So the Predictive Analytics selected 169 variables, taking off a lot of variables that don't need to be considered. No? And with a lot of efforts that here we cannot see, and this is done like in 2 minutes. This is the learning time that the Predictive Analytics needed to achieve a good quality model and show us the results at the screen. So this is, for us, very important because at the moment that we structure the data, the next step, we go to a lot of meetings with the business area and create a lot of different models with a lot of different insights, and this needs to be fast. So we create, for example, models just using weather variables to see all the weather relation to the target. And after that, we see that a lot of the variables don't need to be there. We just took off and run again and create another variable at the same time in the same day and run again. So this needs to be fast. And with the Predictive Analytics and the HANA, you can see that we can teach and create a model just in 2 minutes. It's fast. Even considering the high number of variables, SAP Business Object Predictive Analytics working together in a database can deliver very fast model results, making possible to generate different lines of models in a meeting with the business experts. So it's more than what I said before. And we have another output after after creating the model. We can see that we have the continuous target, and you have data like the minimum and the max range of data in the target, and we have it will use a continuous target. So we have a linear multivariate regression approach with using this automated analysis. So when you open the SAP Business Object Predictive Analytics, you need to select which kind of model are you going to use. So you need to see if it's going to be a classification or if in our case it was a regression to see the past and to analyze the influence of the variables in that data. This is another important thing. We have the prediction power. How I said before, the predictive power allows you to evaluate the explanatory power of the model. In other words, its capacity to explain the target variable when applied to the training data set. So this is the most important thing that we need to have after the end of the creation of the model. If your model doesn't have a very good number for this key figure, you can avoid and try to run again and to take off some variables or have more data because maybe the amount of data that you have is not good enough to create a model, and the 82% of prediction power is a good number. It's considered to be a good number. After that, we're going to see that the tool shows you the number of stars that this means. So we're going to see after. The other important thing to see is the prediction confidence. The prediction confidence defines the degree of robustness of the model. In other words, its capacity to achieve the same explanatory power, the prediction power, when applied to a new data set. So this is another important thing. In general, this number is high. So 90%, for example, is not good. You have to have at least 90 something. And the number of variables that the system caps. Oh, sorry. So here we have a very important chart that shows you the quality of the model that was created. So at the top you can see the prediction power, 82%, that represents like a 5-star model. So for the level of good, the measure of a good model in the predictive power, KI, and in the predictive confidence, KR, you can see that it's much different. I achieved a much higher prediction confidence, 96%, but not good enough. It's reasonable, no? It's like 96%. It's good? No, it's good. No, it's not bad. No, it can be considered. But comparing to 82% of prediction power, the prediction power needs to be can be much less to be considered a very good prediction power. And in the chart, you need to analyze the green line is the line of the data that was produced. How, for example, you have the productivity. How it was the productivity. And the blue line is the line of the model that was created. So the perfect model is always inside, just through the green line. In this case, you see that most of the time you have the model created like following the green line. But at the end, you see like a very great deviation in this part. And this deviation can be a lot of things, but in this case, it was less prevalence of data. So I had much less data, amount of data to train this algorithm, this model at this time. So maybe I can improve my model, trying to bring more data if it's possible. No, you can take an action going to this. After that, you can see the inferences that confirmation. Now you can see all the variables and the level of contribution that they have to explain the target. And here we don't have the names, but you can see that we have the first variable in the left side of the first chart is the first one that explains much more of the target. And entering in this bar of the chart, you can see all the distribution of variables. The SAP Predictive Analytics create like clusters, like you can see like groups of range of this same variable, and show you like the first group contribute something, and the second group contribute like the second bar at the chart below. You can see the level of contribution to explain positively or negatively the target. So when I have data of in the distribution of the first bar at the left, you can see that contribute to have a very good positivity. But when I go to see the group at the right side, at the right, you can see that it has a very good prediction to contribute to have a very bad positivity in this case. So here we have just data from the project that say that in the positivity, the best range that is the positively part contributes like 5% in the positivity and 0.14 in the survival index, and in the normal range it avoids you to lose like 90% in the positivity and 0.21 in the survival index. So this is the part that I said before, that's the simulation. So you can simulate to run this model that was created in the historical data in another cases that you can create. So I can put like, this is the variable that I have, the first part at the top, no? And you can see when I put a lot of values to simulate, it gives me at the part below, the output is going to be the result that we are going to achieve using this data. It's just an example, so you to see that you can use the simulation. You can see with another data, you can like create. In another project, we create like simulation programs using the predictive model that we have here, and give this to the business area to see, for example, how it's going to be something based on something that I have, the scenario that I have now. For example, we had in the past we had a project with the industrial area where I can see all the wood that is coming to be cooked and create the pulp, And how can I cook this food better to achieve more cellulose? So I can see how much I need to use for some chemical or another to achieve a best level of productivity. And at the end, we do the step of valuation. At this project, for example, the Regrowth Conduction, our analysis proved that the appliance of the recommendations that the model generated could reduce the reversal index and improve the productivity in the regrowth areas. Considering the survival, you can see that we're going to have like a strategic gain of 1.7% and an operational gain of 5.7%, in a total estimated gain of 8.6%. And in productivity, we have like a statistic gain of 90% and operational gain of 5%, generating total estimated gain of 14.2%. So this itself sells the project at the end and gives you like more base to defend another project in the future. So people, it was our case here in Fibria. Thank you everyone.